this video, I'd like to discuss various indeterminate forms. We think first about the limit of something in terms of x, which I'll call f of x, over something else in terms of x, which I'll call g of x, as x approaches some real number a, or it could be plus or minus infinity. If the limit of f of x as x approaches a is 0, and the limit of g of x as x approaches a is 0, this is called a 0 over 0 indeterminate form. Similarly, if the limit of f of x as x approaches a is infinity, or the limit of g of x as x approaches a is infinity, then we get an infinity over infinity indeterminate form. And we've already seen in chapter 1 when we were doing limits before that these could be 0, they could be infinity, they could be 4, they could be negative 93. These limits could really amount to anything. They're indeterminate forms because we can't determine what the value is just from this. We need to do some sort of algebra or other technique in order to simplify these limits. We have several other indeterminate forms that we're going to discuss in this section, the first of which is a multiplicative indeterminate form. So we could look at something with an x times something with an x, and if one of these, as x goes to a, approaches 0, and the other approaches infinity or minus infinity, we would call this an indeterminate form of 0 times infinity. Do we have infinitely many zeros, or do we have a whole no infinity? It could be 0, it could be infinity, it could be any real number. And so we'll look at a technique for computing these limits as well. The last set of indeterminate forms we'll study involves the limit of something with an x raised to a power that also has an x in it. And the three types of indeterminate forms that can come from these types of limits would be 0 to the 0, 0 to any power is 0, but anything to the 0 power is 1. So what are these limits? We don't know, it's indeterminate. Similarly, infinity to the 0, a bunch of infinities just means more infinity, but anything to the 0 is supposed to be 1. So what is this quantity? I don't know. The last exponential indeterminate form that we will consider is 1 to the infinity. If I have infinitely many of something, shouldn't that be infinity? But 1 to any power is 1. So these are all indeterminate forms. We can't tell from these expressions what these limits will evaluate to. And our very first technique will apply only to our fractional indeterminate form. 0 over 0, if the top and the denominator, the numerator and the denominator both go to 0 as x goes to a, or the numerator and denominator both go to infinity as x goes towards a, where a is any real number, could be a one-sided or a two-sided limit, or it could be plus or minus infinity. Our first plan of attack for these 0 over 0 or infinity over infinity indeterminate forms is to use this identity, which is only true if we started with 0 over 0 or infinity over infinity, if the limit as x goes to a of f of x and g of x are both 0 or both infinity. Then, in limit, f prime of x divided by g prime of x as x goes to a will be the same quantity. These are not the same fraction. And note that f prime of x divided by g prime of x is not the quotient rule. So we're not taking a derivative here. We are taking a limit. This is not the derivative of f over g. So we are really using a new technique for computing limits. It has nothing to do with computing the derivative of that quotient. We're computing the limit of this quotient. As long as we're in one of these two indeterminate forms and this limit on the right-hand side exists, the limit of f prime over g prime as x goes to a does exist, meaning it's a real number, or it's plus infinity, or it's minus infinity. Then we get the correct answer for our original limit we were interested in, f over g. So in the next video, we'll see several examples of this rule, L'Hopital's rule, put to use for 0 over 0 and infinity over infinity limits. Then we'll move into the other, more advanced indeterminate forms.